Yeah, thank you very much for your kind introduction and invitation to this, amazing event. I'm Kazuhiro Kosuge, currently serving as a chair professor of robotics systems and also director of J-System Lab of Robotics for Soft Materials at the University of Hong Kong. Today's talk is related to the garment production related, robotics. So actually, I was invited here 6 years ago. At that time, I was talking about, in 2019, I think that I was talking about, this is an area which I was doing research at the time. And I think that I was talking about this human-robot interaction. In these days, people call it embodied intelligence. So first, I'd like to briefly show you some interesting videos as the starting point of my introduction. This is the most well-known robots from my group. It was unveiled in 2005. This is a dance partner robot. Actually, we developed a field dance partner robot using the Hillmarkov model to estimate the male dancer's intention. Because in the ballroom dance, male dancer leads the dance, and the female dancer needs to coordinate with the male dancer by estimating, by knowing how he would like to dance. That is true up to the intermediate class. Of course, for the expert, it's a little bit different story exists. But this is what we developed a long time ago. Okay, and as a kind of application of this intention estimation mechanism, we developed PADI. This is a parts and tools delivery to you robot, okay, designed for the automotive factories. And actually, it was introduced to the companies, one place in some company in Japan, and was used it. And okay, but today's talk is in 2021. I joined the University of Hong Kong and started a new research on robotics for soft materials. We are also started research on garment production in the Center of Transformative Garment Production, funded by Innovation and Technology Commission of Hong Kong, and as a part of HK program. So most of the contents are coming from this project today. So let me introduce why I'm doing that now, and how the AI technologies can be, used for that area. And actually, robotics and emerging AI technologies, I think that I assume that most of you are coming from AI field, and these, based on the emerging AI technologies, robotics and emerging AI technologies have enabled the automation of many manufacturing processes regarding handling rigid objects. I think that many people say, when I'm talking about industrial robots, many people told me that we have nothing to do now. But it is not true, okay? Actually, there are many difficult manufacturing processes that are difficult to automate using robots. One of the typical processes is related to the manipulation of soft material objects. Most manufacturing processes, including the soft material objects, are performed by skilled human workers and are very difficult to automate. This is true. You may not know exactly what I'm talking about. Like garment manufacturing is one of the typical one. Shoemaking, making wire harness. Many robotics companies are trying to solve this issue. And carbon fiber pre-leg mold, and cutting and deboning meat. Concerned with the meat processing, there's some robots exist, but still not complete. Several companies are developing technology which can be used for food processing. Okay, going back to the garment industry, you may not know how big it is. Global revenue in apparel market is expected to reach 2.3 trillion US dollars in 2030. This is a huge market, right? And what is interesting, this is an industrial robot used all over the world. The data is a little bit old. It's in 2019. The biggest five biggest users of industrial robots include China, Japan, United States, South Korea, and Germany at that time. And in China, at that time, 6 years ago, about 110,000 units were introduced, and only 157 units are used for textile-related industries. In Japan, among the less than 50,000 units, only 13 robots were used in textile industries. Okay? But compared to the size of the apparel industries, this is so small. So garment industry is a vast industry with minimal adoption of robotics. Okay? And actually, looking at investigating a lot of literatures, 80% of total production time and cost is spent for material handling. Okay? What is interesting? This is relating to the apparel manufacturing processes. Actually, the 67% of labor distribution in apparel manufacturing processes is dedicated for sewing. So sewing is the most intensive process in garment manufacturing. And of course, several people, started in the past. Many people are doing research relating to the, how to automate the garment production. And one of the most well-known research team was Paul Taylor's team in UK. And actually, they developed a lot of technologies from 1980s and the 1990s. And suddenly, everything has been closed. This is one of the examples. They developed a lot of tools for automated assembly toolbox. This is an example of 2D sewing and 3D sewing systems. And some of the concepts are used today is a semi-automated sewing system. Semi-automated means that a human is involved to utilize a machine. I'm going to explain it later a little bit. Garment production actually includes a lot of difficult processes like cutting, folding, edge folding, stitching, pocket setting, sewing, top stitching, ironing, and so on. Many, many difficult processes exist. This is one of the examples. The left-hand side is a fabric multi-layer cutting. Suppose that you visit some garment factory, you can see, in order to, they don't cut one by one, right? This is the first step to produce a garment. They layered, multiple layered fabrics are cut by using NC control, numerically controlled machines. So cutting is okay, almost automated. And that is another one is from mica. This is a kind of folding this, this portion. There is a special machine to do that. But still, human needs to be involved in that process. This is another one. Oh, it doesn't work. Just wait a minute. Okay, this is a current sewing machine and a semi-automated sewing machine. You can see that how it is done. Because the fabric is so soft, they use a template or clamper to make the flexible fabric solid in some sense and operate it like a rigid body. That is what they can only do. And on the right-hand side, you see that this is a pocket setter, and there is a kind of template or a fixture designed for that pocket. So if you like to, you'd like to sew different types of different shapes and different sizes of a pocket, you need to redesign that system. Okay, so today's semi-automated systems have been developed for mass production of goods, and which has led to the de-skilling of some process. De-skilling means make it possible to be used without much training. Okay, and semi-automated system requires, but unfortunately, these systems require reconfiguration of the system for different design and the different size of the garment. Like tailor-made templates for edge folding is needed, tailor-made templates for each sewing process is needed, and the programming, of course, you need to program the machine so that it can solve the given target. So in our project, we started to develop key technologies for handling and sewing pieces of fabric without the use of fixtures or templates. We call it fixtureless, and without operators training. We call it the de-skill. And we have developed several technologies for that. And let me explain some of the examples of these technologies which we developed. The first one, and the hand of fabric parts. As I mentioned, usually fabrics are cut together, so you have to pick like a right-hand side, you can see that the fabrics are cut together. So in order to assemble the garment, you need to pick up one by one. But this is not so easy, even for us. Okay, so we developed a PAL grip. This is a passive actuatorless gripper, which can pick up one by one. Pick up the topmost fabric from the stack of the fabrics. Okay, and actually, this is, we call it actuatorless means there is no actuator installed inside. It's a passive mechanism. So relative motion between the housing of this end effector and the fingers generates the gripping motion. And also mechanical logic is installed inside, so you can repeat this. You can repeat the pick the topmost fabric and place it to some area. So we developed something different versions. Okay, I think I'd like to skip it. Okay. And another one is again that this is a pick and placing, but in this case, by using two manipulators, two arms in coordination, we can more precisely place the fabric on the specified place. Okay. And since that in this case we installed a sensor which observes how many fabrics are picked up, and since that this uses a suction slot is so easy. Sometimes several fabrics are sucked together. So in that case, the system can detect the failure, and the failure recovery motion will be carried out automatically. Okay, I have plenty of slides. And this is, I think that most of you are coming from AI field, so you can see that edge detection. Actually, currently around 120 frames per second can be processed using AI technologies, which can detect the vertical edge as well as this. Purple dot shows a kind of a horizontal edge. So using that one, this one, we can control the sewing process. Okay, concerned with sewing, I told you that 67% of the labor is distributed for sewing. So we are serious about sewing ones. And we have developed several technologies. Concerned with the use of ordinary industrial sewing machines. I'm not sure whether you are familiar with sewing, but sewing is not so easy, okay? Feeding motion actually, fabrics are fed automatically by the sewing machine. Which we can do is just rotate the fabric around the needle, right? So by just rotating the fabric around the needle, we need to control the trajectory of the needle. So this is from control point of view, this is called a so-called a non-holonomic process. But my student successfully designed the controller and make this one. Wait. Okay, I'd like to skip this part, but okay. Yeah, you will see that how it works. So by just, manipulator can be controlled, control the fabric rotation, orientation to the feeding direction. So in this case, we can theoretically solve any curve, smooth curve, as long as it is smooth. So, the sewing line converges to the designed sewing line. In this case, defined relative to the edge of the fabric. Okay, combined with this one, we can also do a little bit more intelligent look like, a robot look like sewing system. I hope you can appreciate, you can identify this is a kind of embodied intelligence. I don't know. The machine can sew like humans, okay? If necessary, it can rotate the fabric around the needle and sew it. Okay, recently, this is accepted as a paper. Okay, this is so by using this system, without the programming, we can sew different types of similar shapes of these parts. Okay, and there are many, many different ways to realize that. Another one is this is another fully automated one. By using the vision system, the robot knows where the fabric is located. And using the AccuPick, it can place it on the, put it on the first fabric. And in this case, we used only the sewing head. And then the fabric is manipulated so that it can sew based on the designed sewing line defined relative to the edge of the fabric. And also, using the current AI, we can align the textures. Okay, this is a little bit complicated texture. On the right-hand side, you are the alignment error. Okay, and by using the vision system in real time, we can align these two textures. Okay, this is the results. But you can see there are two different types of fabrics, right? So this is what we can do. So current AI is very, very, powerful. So we can do something which we couldn't do in the past easily. 3D sewing, if I had a time, I'm coming back to this one later, but this is really important. 3D sewing is a technique crucial to producing a variety of items with 3D shapes from flat fabric. 3D shape can be created by rotating upper fabric and lower fabric independently around the needle. Okay, so we successfully developed some system which can sew the two different fabrics together along its own sewing line. Okay, we hope that this is kind of a, we are sure that this is very important technology, especially for car seat sewing and car cover seat sewing. And we don't need any programming. Okay, sensor is there. So by just setting a robot, setting a material and turn it on, we can sew the fabrics together to create 3D shape. And actually, this shape is originally coming from the Tesla's seat cover, which we bought from Taobao. Okay, this is another one. People say that you don't need to use a robot. So we just implemented a robot to fully automate this process. So by combining the two robots and this sewing machine, 3D sewing is carried out automatically. This robot is programmed by a person who is not familiar with robots. So motion is a little bit jaggy, but it works. The same. The later is the same. Maybe, sorry, I couldn't feed forward. I couldn't speed up because I'm using clicker, so it takes longer. And very slow. That's the same sewing system, but you can see that after sewing, and this is unfortunately, this hasn't have this sewing machine is a cheap sewing machine. It didn't have a thread cutter, so it had to cut it by itself. But the robot can do that. See? Now that the next one is before sewing. This is for shoulder joining of T-shirts. You need to align two fabrics together, right? And it doesn't work. So by using the Archipic concept and using some technique which can align the fabric by using the partial information of the image, you can see that the fabric can be aligned. Okay? And after this, we can actually sew these two fabrics together, but okay, for more, fundamental research, we are doing kind of fundamental ones. I have no relation with this company, but we found a very nice video, YouTube video, which shows that they need to handle a piece of fabric in the factory, right? When handling such a piece of fabric, you need to plan the motion. So motion planning is very important. But in order to plan the motion, we need to model the dynamics of the fabric. But it's very difficult. And using the transformer, this is we carried out the motion planning. Using a transformer, we model the motion dynamic motion of the fabric, and based on that, we plan the motion. Okay, and this is a 3D case. You can see that planned motion can avoid collision between the fabric and obstacle. This is possible because of the recent advancement of machine learning. Actually, you use a transformer. Okay, and many people are doing flattening and by grasp and fringing. So we also developed some technology which can be used for flattening by fringing motion. And what is important is that this is not this is an unseen object. We train the controller using another fabric, and the same controller can be used for multiple garments, T-shirts like garments in this case. Okay. This is fun, but we don't have so many applications for that. So we try to find that application of this one, and we find that maybe previous example of Shenzhen company's one is how to pick up the printed fabric piece and put it into the next stage. But for bringing the fabric to the printing board is not so easy, right? So one of our student, try to do that. Now we can do it using kind of a special technology for that. And I hope we can use it in the future. Okay, as a conclusion, how much time do I have? Do I need to close? That I can close. If I have 3 minutes, I'd like to explain a little bit more, okay? Okay, as I mentioned, 3D sewing is very, very important. We are now seriously thinking about how to commercialize this system, okay? So a garment is not so expensive. So the garment companies do not have, do not want to invest so much. So we consider maybe car seat is, considering from the volume of everything, car seat is a first step to bring this 3D sewing systems. And our technology is affordable and easy to use. Easy to use that without programming, we can use it. Affordable means based on existing industrial sewing machine. This is not so expensive. And going back to the market, in 2028, automotive seat covers market is expected to reach around $3 billion US. Compared to the apparel, it's smaller, but the price is more expensive than the cheap apparel, right? So I think this is very important. And also, industrial sewing equipment market for car products is expected to reach $363 million US in the year 2028. And what is interesting, the most largest market is in Europe. Second one is China, North America, and Southeast Asia, and Japan. So what is good is European market. This is a minimum wage of Europe, and the European minimum wage is very, very expensive, very high. So which means they need to automate the car seat production if they'd like to continue the business in that field, in that area. So this is a most recent version, I think, I would like to. I would like to turn off the sound, right? This is the actual car seat parts, and this is the final slide. Now, same as before. By just setting the two real car seats fabric, and on the I hope it now starts to move. Okay. Oh, this is an amazing video. I mean, if you are working in this field, this is really amazing. And I hope some company is going to commercialize this one soon. Okay, so the sewing line is very precise, and along not only the sewing margin, but also along the sewing direction, it's completely adjusted, controlled. Okay, thank you very much. This is our team. I hope some guys are interested in our 3D sewing system. I mean, help us to commercialize it. Thank you very much for your kind attention. Thank you.
Thank you. Thank you for